All right, hey, Kelsey, this is the backside of the notes for 10-3. We're going to start with example 2. Part A, we're putting each one of these in polar form. We learned how to do this yesterday, but I'm going to refresh you, and I'm going to show you how to check your answer. It's really wonderful and really nice and easy. So on the test, you can check your answer when we test over this chapter, which will be a ways from now. But A, if we go to graph this thing, let's just do a rough sketch of what this looks like, okay? -3, or negative square root of 3 is how much we're going to the left. So we're just going to go over, I don't know how much square root of 3 is. Negative square root of 3. We're going to put it like that, okay? And then what's this value right here?
It's I.
1. It's I, right? 1I. So we're going up 1, okay? So I'm going up to 1. So I have this. Let me put my square root of 3 on the bottom. Yep. Negative square root of 3. I'm going to connect them back down. I'm going to make it into a triangle. So this is 1, right? There's my triangle there. Good? Happy with that?
So good.
Okay, so we have to express this in polar form, which is r cosine of theta plus I times sine of theta, yeah? Okay, all right, r, we need to figure out what r is, and r is just this distance right here. So it's like doing the Pythagorean theorem. It's like finding the radius, right? Okay, so I square everything, right? Okay, this is like, this will be your A and this will be your B, whatever, right? 1 squared plus negative square root of 3 squared equals C squared, right? Okay, all right, 1 squared is 1. The square root of 3 squared
3.
is just 3, right? Is it positive 3 or negative 3?
Negative, positive?
The square always turns it positive,
Well,
right?
but it's going to be negative at the end.
No, wrong.
But why did you put the negative outside of the square root then?
Because you can't have
Because you can't have a negative inside the square root.
It's
But you're still
imaginary.
squaring the negative,
Oh, okay.
right? This means negative square root of 3 times negative square root of 3.
Whatever the square root is, you turn it negative. I've always
Right.
thought that.
Yeah.
That's what it is.
Well, you take the square root of the inside and then you make it negative. That's all. But when you square it, the negative goes away. So 1 plus 3 is 4. 4 equals C squared. So C is
What's your
2.
problem?
2. C is 2. Here's my 2. That's my side C. Okay? All right, so R is 2. When we go to put it on our polar form, 2. And then we have cosine of whatever theta is plus I times sine of theta, whatever that is, right? This is actually a special type of triangle. Do you remember which triangle does 1, 2 square root of 3?
1, 2 square root of 3.
Yeah, what triangle does 1, 2 square root of 3?
It's 30, 60, 90.
30, 60, 90. So is this angle right here a 30, a 60, or a 90?
60.
You think it's 60?
Yeah, because the 30 is the skinny side and the 90 is the thing.
It's 30. We'll find out though. So let's do tangent. Tangent of theta equals opposite. Which one's the opposite?
1,
1. We'll do 1 over.
the square root of 3.
Adjacent is negative square root of 3 or whatever. Then we do inverse tangent. So theta equals inverse tangent of 1 over negative square root of 3. Do that in your calculator and see what you get.
30.
You get 30?
I don't know.
22.
I don't even have my calculator ready yet.
22.
Inverse tangent of 1 over the square root of 3. It's 30. But it should be negative 30 actually in your calculator, is what it will come up with. But do it real quick.
Negative 30.
Negative 30,
but we
okay.
have to express
But here's the problem. We talked about this yesterday. I don't want to put 30 degrees inside of here
150.
because it goes from here to here. If this is 30 degrees, what is here to here?
150.
150. That's what we're going to put in here. Okay, so this is my polar form. That is my answer. Are you ready for how you check your answer?
Sure.
No.
This is super easy. You're going to use your calculator to check it. Ready? Okay? You're going to use your calculator to check your answer. Do this really quick for me. Okay? When you have this 2 out in front, you take 2 and you multiply by cosine of 150. What is 2 times cosine 150? 2 times cosine 150.
7.
Negative 1.73, yeah? Plus I times what's 2 times sine of 150?
1.
Is it 1 or negative 1?
1.
Positive 1? Yes? 1 I, right?
And the square root of
This
3 is that.
is the same as that. We just use the calculator to get back to the original answer, right? Checking your answer really fast. Take 2 times cosine 150. You should get negative square root of 3, which we got as a decimal, right? 2 times sine would be positive 1i, right? That's how you check your answer. Really fast and easy. It's like a no-brainer. Do it. Okay? B, let's do this one in polar form. Here we go. Plot him. What quadrant will he be in?
2.
2 also. So -2. Whoop. -2 plus 5. He is there. -2. We're going to make him into a right triangle. So -2, +5. We've got to figure out what the hypotenuse is, which is our R. So we do -2 squared plus 5 squared equals c squared. This is 4 plus 25 equals c squared.
Square root of 29.
29 equals c squared. We're going to leave it as the square root of 29 if it doesn't come out nicely, right? c equals the square root of 29. Okay? So when we do r, cosine theta plus I sine theta. R is going to be my square root of 29. Okay, now we just have to figure out what our theta is. Theta is this guy that lives right here. There's my theta. Okay, so I'm going to use tangent again. You always use tangent. We have tangent of theta equals, what's the opposite?
5.
5 over -2. Then to find out what theta is inverse tangent
112.
of 5 over -2. And you said what?
Oh, and arctangent.
What's arctangent?
Is -68.2.
-68.2. But we don't want to write it like that. 68.2 is this angle right here. 68.2 degrees. It's going to measure from here to here. So we have to reflect that it's in the second quadrant, which means it has to be more than 90 degrees, right? So how do I figure that out?
Plus 180.
Yeah, so we're going to subtract this 68.2 from 180. So like 111 something
It's
degrees.
112 if you round.
112. We'll just go 112 degrees. So we have cosine of 112 degrees plus I sine of 112 degrees. Okay? All right, now check your answer. This is our polar form. Listen. If you take the square root of 29 times cosine of 112, you will not get -2 exactly, by how's come?
Because we round.
We rounded the 112, right?
Yeah.
But you'll get something close to -2. If you take the square root. Yep.
And
So
just
if you
not
take the
five.
square root of 29 times sine of 112, you'll get something close to 5. It won't be exactly, but it'll be close, right? Because we rounded the 112. That's how you check your answer. You might as well do it. Like, it's really super fast and easy. Really super fast and easy. But that's polar form, right? Okay? Now, we don't yet know what polar form is useful for because this, to me, looks uglier than this. So why would we do that in the first place? We're going to find out later on. Like in the next section, when we start to like talk about projectiles and vectors and stuff, we'll do that. Okay, they're not too bad. They're not bad. They're not bad. It's gonna be fine. Okay, so just keep that in the back of your brain. That's how you switch to polar form. It is an uglier form than regular complex numbers. Like this is a complex number, and this is polar form. Polar form. So like polar form is uglier than complex numbers, but keep in mind that's what we're going to use to do computations later on. Okay. All right. Now we're going to be adding, subtract, or we're going to be multiplying and dividing.
Oh, God.
Woo! So take a look at this.
What?
Shh.
Sorry.
Shh.
Sorry.
Okay. They want us to multiply, and they have Z1 and Z2. That's just standing for like Z1 is this polar form, Z2 is this polar form. They're wanting us to multiply those together because these two are right next to each other, which means multiply. You see that?
Oh, no.
Okay, when you're multiplying, here's the rule. Ready? We want to combine them all into one. We want to have one final answer of R cosine of theta plus I sine of theta. That's what we want to have as our final answer, but we're combining two of them into one. Okay, you have got to listen. Okay, so if we have two of them and we're multiplying, this is the R for the first one, this is the R for the second one. What do you think we're going to do to find our final R?
Multiply.
We're going to multiply. It's going to be 6, right? Okay. Now, this one is 5 pi over 6, and the second one is 7 pi over 4. But the problem is, we don't multiply.
Add.
Okay, the formula up here, if you want to look, says that when you're multiplying, you do multiply the R's together, the front numbers together, but you add these. To figure out what this theta is, you add these guys, and you add these guys, okay? This one you multiply to get your R in front. That's just the way that polar form works. So, to figure out what our theta is, we have to add them, okay? All right, don't give me a decimal when you're adding. We're almost done, guys. We're adding 5 pi over 6 to 7 pi over 4.
This is weird.
We're adding 5 pi over 6 to 7 pi over 4. Shh.
No. Oh,
All right, don't give me a decimal.
Sorry.
Don't give me a decimal. How do we add those two together?
Change the bottom.
We have to find a common denominator. 6 and 4.
24. 12.
12. Let's do 12s, right? Okay. This would be 12 and this would be 12. Ooh, so we have to multiply by 2
Pi over
and multiply by 3.
10 pi.
21.
So this would be 10 pi and 21 pi, yeah?
31.
Correct. So
31 pi.
pi over 12.
31 pi over 12. Okay? You're finding a common denominator and you're adding them together. So, when you're multiplying, you're actually adding those guys, and this is 31 pi over 12. And 31 pi over 12.
Oh my gosh, so is it subtracting for division?
It's subtracting for division.
Who would have ever thought?
Who would ever thunk? So that was multiplication. You multiply the r's out in front, but you add the thetas.
Hold up.
You multiply the r's, but add the thetas.
She's just not gonna be able to have it. Oh, okay, that's kind of.
Okay. Next one. This is division. It says find z1 over z2, which is another way of saying divide. Right? Okay, so r's out in front, the same thing. I'm going to do r cosine theta plus I sine of theta. This is eventually what we want to get to. To find this r, we actually do divide them. But to find this theta and this theta, when we're dividing, we actually subtract them. It's kind of like the log stuff. Plus means multiply, minus means divide. Okay? So, what's my r out in front going to be? 5. 10 divided by 2 is 5. Okay? Then we've got cosine of whatever my theta is plus I times sine of whatever my theta is. And I have to subtract them. Okay? What am I subtracting? I'm going to do off to the side.
12.
Pi over 3 minus pi over 4. Okay, this is subtracting. So, we want to find a common denominator. Again, it's going to be 12, right? 12s and 12s. So here I multiplied by 4. And here I multiplied by 3. So this would be 4 pi and this would be 3 pi.
So pi over 12.
So 4 pi over 12 minus 3 pi over 12 is 1 pi over 12, yeah? Or just pi over 12. You don't need the 1. Okay? That's what I'm going to put in for my thetas. That was going really fast. Was that too fast? No, not too bad? Okay? That is multiplied together, okay? That is leading you into what we're going to be doing in the next section. When we start to, so the way that this works is we're going to be having vectors. So like think of this as like, this is the angle that something is shot out of a t-shirt gun, right? It's shot at a force of 10 at this angle right here. That tells you the angle, cosine and sine, right? That's my t-shirt gun, right? I'm shooting at a t-shirt, like out of a t-shirt gun.
Hey,
And then it is being combined with that, which is like the force of the wind, right? Like if I shoot the t-shirt gun out and the wind is blowing, it's not going to end up going where I aimed it, right? I have to figure out if this is the wind force, we're multiplying those together, and that's what we're going to be doing next, right? So we have two vectors or two forces that are multiplying together. We'll get to that eventually. But it's this process, right? You're multiplying the angles, adding the angles, that type of thing, okay? That's what we're getting to eventually. Multiply means adding angles, dividing means subtracting angles. Good? That's what the entire backside is. Do all of them on the backside?
Do we have to write them in the a plus bi form?
What?
On the back?
What?
On the back.
Yes.
How do we do that?
Yes. Oh, good question. Good question. One more thing. On the back side of your homework assignment, go back to this page, your bottom example. They're saying write it in polar form. So they want you to multiply and add, or multiply and divide. Write it in polar form, and then also write it in a plus bi form. So how do I go from polar form, this guy, to a plus bi?
5 times cosine of.
Okay? Do in your calculator. 5 times cosine of pi over 12.
Okay.
But, hold on. Pi over 12 is a radian.
Oh, yeah.
So you need to have your calculator in radians
Oh my god.
when you multiply it through. So switch your calculator to radians. Sorry, go to mode. Switch it to radians because you're taking cosine of pi over 12, right? 5 times cosine of pi over 12. Okay. So go to radians, switch it to radians. Tell me what 5 cosine of pi over 12 is. Somebody. 5 cosine of pi over 12. I'm almost done. Ha.
Can you go back up?
What is 5 cosine of pi over 12? 4.83. Okay, so 4.83 plus, that's your A, plus B will be 5 times sine of pi over 12. Do that. Just go back and switch your cosine to sine. 5 times sine of pi over 12.
Where are we getting out work on that one?
So A plus BI, what's your
1.3.
1.3. So that's how you switch to A plus BI form. Good?
Okay, if you have
Okay.
something like 6 pi over 12, can you reduce that to
Yes.
1 pi over 2?
To pi over 2. Yes. Was that when you were multiplying?
Yeah.
Then that means you didn't use the least common multiple to start with. Probably.
What?
Maybe. Maybe not.
No,
Maybe
I'm
not. Maybe not.
adding 5 pi over 12 plus pi over 12, and I got 6 pi
Okay,
over
you're fine.
12.
Yes, you can reduce.
You have to.
It won't be wrong, no.
Okay.
Technically.
So if it's 7 pi over 7.
Then it would just be pi. Right. Okay, good. Any other questions before I stop the video? Bye, Kelsey.
Bye.
There you go.